of Euclidean Geometry calculation for yeah. So the first things we have, these are the basic principles that you might have learned from grade 9. And we look at things such as things that you can work around with your positive points. We have your vertical opposite that comes as 1 is equals to 2, and you have the fact that angles in a revolution will come to 160. When it comes to your parallel line, you have corresponding angles. So in this case, this one and that one corresponding angles. We have alternative angles which give you a z. So then in this case, it will be this one and that one. And you also have your pointillion angles, which is this one and that one, that should add up to 180. With regard to triangles, we know that the sum of all triangles is equals to 180, and the clear angle is equals to the sum of the two opposite angles. If the two sides are equal, then the two angles are equal. And the reverse is true. If the two angles are equal, the two sides are also equal. We also have your right angle. Here, between the continuous perpendicular statement to calculate any of the missing sides. And then we have congruency. Congruency means that you have the same shape in both sides, so you can prove it with regards to 4 ways. First way that you will prove it is your side. If all the sides are equal, then you will take triangle. Then you have your angle side angle. So angle side, and you know that the two angles are congruent. If you have your side angle side, please ensure that the angle is in between, and you know that they are congruent. And if it is a right hand angle, then we only have to prove that the two sides are equal, and the fact that it's right angle, that's the geometry. Right. We prove two sides are equal, then we go. Right. Okay, so this is your circle theorem that you have learned in grade 11, and it is grouped according to what it's dictated at. So for us, this is center equations. So whenever you are given a question and they use the word center, these are the theorems that you would possibly use. The first one is that an angle passing through your center, passing through the chord, will cut the chord in two. Right? So it must cut it perpendicular to cut it into two. The line is to be center and perpendicular, then you know the two are equal. And if the line is going through the center and the two sides are equal, then you know that the angles are perpendicular. Right. And the next one says the angle at the circumference is twice as much as the angle at the center is twice as much as the angle at the circumference. And these are the 3 different ways that they can show this. Right. And then the last one is that the angle in a semicircle will have a 90-degree overlap. So if in your question you see center, by all means, this is the things that you should be looking at if they show you there's a center. Let's move on to your cyclic quads, right? For something to be a cyclic quad, all of the vertices needs to touch the circle. All of them. That's how you know it's a cyclic quad. If not all of them are touching, then it can't be a cyclic quad. Now you can have them not touching, and he's asking, is this a cyclic quad? It means that then if you need to prove that it's a cyclic quad, any of these rules here will allow you to prove that something is a cyclic quad. So in a cyclic quad, the angles add up to, the opposite angles add up to 180. So A and B here that's 180. If they want you to prove that something is a cyclic quad, then you would shape the cyclic quad, you would need to prove that the two opposite angles are equal to 180. That's one of the things you can prove. Another thing that you can prove is that the exterior angle is equal to the opposite angle of that angle over there. So the exterior angle is equal to the opposite interior angle there. And then the last one is angles in segment. So to show that A is equal to B or C is equal to D. So these are true for cyclic quads. If they say something is a cyclic quad, these are true for cyclic quads. And if they don't say the cyclic quad and they want you to prove it, you can either prove it by showing any of these is true. The next group that we have here is the tangents. So if they tell you that you have a tangent, you can assume any of these, right? You can assume that the tangent is going to be perpendicular to your radius, right? Or if they want you to show something is tangent, this is one of the things you can try to prove, that it is perpendicular to the radius. Then you can say the two lines are, the line that's passing through is a tangent. And the next one is that if these two are tangents at the same point, then PQ will be equal to RQ. Again, you can prove that the two lines are equal. Then by proving that, it means that again, these two lines are tangents. The one we have, another one we have here is your 10-chord theorem, which says that this angle over here is equal to that angle over there. I'm always asked, how do I tell which angle it is, right? After you get that angle, you count one, and then the next angle is it, right? So for me, that angle, I count one, and the next angle is it. That's how I show that these are 10-chord theorems. So again, another thing is that you can do the opposite. They can say, please prove that PA is a tangent. If you can prove that C is equal to P1, then you can prove that it is a tangent because it follows the 10-chord theorem. Okay, so in grade 12 now, we learn new rules. The first rule is that a line drawn parallel to one side of a triangle divides the two sides proportional, right? What does that mean? It means that then A over P over B over P is equals to A over Q over Q over C. And the opposite is true. If you find that these two sides are proportional to that two sides, then you can say that this line over here is parallel to that line over there. The important thing that you need to be able to use here is proportionality, it's ratios. Ratios are going to be important for you to understand how to work about with regards to these questions here. We also have the midpoint theorem. It says a line drawn to the midpoint of two triangles parallel to one side will then bisect the side in two. So if this line is then midpoint between A and B and also midpoint between A and C, then it will cut them into two. That means that then they are proportional to each other with a 1-to-1 ratio. Okay. So being able to use ratios and fractions is very important here. You should understand that if I have something that is written as AB to BC is a 2:3, it means that AB over BC is equals to 2/3 in this way, right? And we need to understand that ratios do not necessarily show us the length. They show us the relationship with regards to the length. So let's look at here. They say AB to BC is equals to M to N, M to N. So then you're going to let AB be equals to MX. That means that BC is then equals to MX. So let's see. If AB is equals to BC, right, then we're going to say let AB be 2x and BC be 3x. necessarily does not mean that X is any length. It could be, it's something they share in common. It's just for us to understand the relationship that we have between one length with the other. So in this case, AB is 2 times X, whereas BC is only 3 times X. So you need to be able to understand that ratio there. I think when you do that, it makes these ones a little bit easier to deal with. Then we get to the area ratios. Here we have two triangles that share the same perpendicular height, and if they do share the same perpendicular height, then the areas between them would just be equal to your bases over the other base. As simple as that. So the ratio of their area is equal to the ratio of their base. That's if they share any perpendicular height. Then if they have a common angle, in this case they have they have A that is common with them, right? We can even see that we have also parallel lines. Then we adopt the rule that says ratio of the areas will be ratio of the corresponding sides of AP over BP and AQ over AC. To see more on how to solve these questions, please head on to the Fundamanje YouTube channel or head on to the site so that you can see how these rules are used.